Hello and welcome. Myself, Mr. Bulakeba, Ashok Rayat Shikshan Sanstha, Abasaheb Marathi, Arts and New Commerce Science College, Rajapur. Today's lectures we are going to discuss the topic synthesis of organic compounds. In these topics, last times we have seen the various types of synthesis can be done by using the 12 principles, and these 12 principles which are shows the pollution can be controlled, and therefore such a type of synthesis which are used in basis of the 12 principles. Now today's lectures, now we have going to next point, that is the use of the green solvents. By conventional method we are used various types of solvents like carbon tetrachloride, acetone, benzene. But such a type of solvents which are carcinogenic and which produce the pollution and which affect to the environment. And therefore, you know that in traditional method by organic synthesis, we are use these chlorinated hydrocarbon solvents. It has the number of pollution problems, and therefore we are use the solvents which are eco-friendly. For example, one such solvent is supercritical carbon dioxide, which are at 31 degrees centigrade. The solvents which are non-toxic, non-flammable, and as well as they are the renewable and inexpensive. So this is the property of that solvents which are the mostly useful to the organic synthesis. For example, the free radical bromination of a toluene can be take place in presence of by using the solvent is a carbon dioxide, and hence N-bromosuccinamide it get 100% conversion of benzyl bromide. Also, the industrial application they include the polymerization as well as the essential of oil production process it can be used. So various types of applications can be done in industries due to such types of characteristics like a non-toxic, non-flammable, renewable, and inexpensive type of reactions. The next point we are going to discuss like the catalyst. Various types of catalysts we are used in the organic reactions. These catalysts which are harmful to the environment like platinum selenium dioxide, lithium aluminum hydride, or sodium borohydride, sodium hydride. So number of catalysts which are used in organic synthesis by various type of conversion can be take place. But you know that this conversion can be happen with the help of enzymatic catalyst, and those catalysts which are some of these advantages. But you know that this organic convergence can take place in industrial importance with the help of enzyme like another name is a biocatalyst. So advantage of this catalyst are, first advantage, the reaction can be carried out in aqueous media. So such a type of solvents which are not harmful to the environment. Next characteristics, the reaction can involve only one step. So single step of reaction can be proceed. Next advantage is a deprotection and protection of the functional group which cannot take place. The one of the applications we are see in this green chemistry, like protection deprotection, must be avoided as far as possible, because such a type of protection and deprotection process, the number of solvents which can be wasted, and these solvents which can affect the environment, as well as the derivatization process, which also the number of waste byproducts will be produced. Next type of advantage is reactions are fast and exhibit the high degree of selectivity. So selectively reaction can be carried out by using the enzymatic catalyst. You know that the by traditional method, the some catalysts we are use, like sodium borohydride, which are selectively reduce only the polar functional group. Another catalyst also we have see that is the Lindlar catalyst. The Lindlar catalyst also we are used for the cis alkene reaction. Another type of catalyst, like NBS, N-bromosuccinamide, those catalysts also used for the selective allylic and benzylic bromination reaction, and hence these traditional catalysts which are selectively produce the product in the reactions. Same like to the enzymatic catalyst, another name is a biocatalyst, which are useful for the selective type of reaction can be done. For example, it is a this hydroxylation of nicotinic acid. Hydroxylation of nicotinic acid can take place in presence of the O2 by using Azotobacter xylococcus, sorry, xylosoclans as a bacteria, which are selectively hydroxylation are take place at this sixth position in this nicotinic acid. Another examples, like the selectively reduction of ethyl acetoacetate can take place by using Baker yeast. These Baker yeast are used for reduction of this carbonyl carbon with the help of these biocatalysts, and to produce selectively the S alcohol. So selectively reduction can be carried out, does not reduce this ester carbonyl group, but only reduce the ketonic carbonyl group. We have see this reaction, two carbonyl are there, one of this ketonic carbonyl, and it is a ester carbonyl, and Baker yeast can reduce only the ketonic carbonyl group to corresponding alcohol. So that is a S configuration. Why it is a yes? This is a 1, this second, this is third, and fourth is a proton. So it is clockwise direction, but it is showing R, but yes configuration. So yes alcohol it will be produced. Next point we have going the planning of organic synthesis. Now it is a very important point out that the planning can be done before the beginning of the reactions. So various types of planning are much important for decide the various types of organic synthesis. Before we have going to the preparation, one has to understand the basis requirement for the chemical reaction is their properties of the reactant and products, including whenever protection of any group is necessary, yes or not, or so the feasibility of subsequent deprotection under desired condition also has to brought out, or another, whether the any undesired intermediate can be formed in this reaction. In such a situation, the special suitable modification can be avoided will take place and or minimize loss the undesired reaction carry out necessary by stoichiometric calculations as well as expected yield. For proper planning, we can done by deciding strategy of an organic synthesis, but one array can be carried out like a retro analysis or retrosynthesis of the compound, and we are decide upon the most feasible route for the organic synthesis. Next important points also it should be study the MSDS of all chemicals can be used in the reactions along with the product, possible the byproducts which may form in the closure of the reactions to adopt necessary precautionary measures for safety. All can be concerned with these type of reactions. So such types of very important basic concept or basic steps which are important for the organic synthesis can be done, and these steps which are very important for the planning of organic synthesis. Now we are some examples we are see this synthesis. First synthesis we have see the synthesis of nitroaniline. So two types of nitration reaction. First one ortho and next one is a para-nitroaniline. So firstly, the ortho and para-nitroaniline can be prepared by reacting the corresponding chlorobenzene with the 25% the ammonia at about 170 degrees centigrade at about and 35 to 40 atmospheric pressure. So first reaction are like the amine at 25% is amines, and then these amines which attack, so this nitration or through position nitration can take place by attacking the ammonia. Next, para-nitro chlorobenzene. So this ammonia at high atmospheric pressure like 35 to 40 atmospheric pressure, it required to get the chlorine is replaced by NH2, and to get amination can take place at this position. So para nitro aniline will get the products, and ortho nitro it will get the product.